Welcome everybody. This is the presentation. So we are discussing today, and I will show you the analysis that we have done in the lane management model that will support some specific use case. Some of them has been already anticipated by Joseph Kaltwasser presentation. Lane carriageway management modeling. The aim is to implement a further vision on respect on the current location referencing vision that allows to manage logical information on lane, but with some limits. The situation publication, for instance, it supports the description of lanes needing multiple records to specify several lane management configuration evolving along the carriageway. I will explain it later. If you use the current model for managing different lane management configuration, you need several situation publication records. The application of having a precise lane status information is real and is generated more and more in specific road management use cases, such as the dynamic lane management through the lane control system, which are specific VMS specialized to manage the information of the lane transitability, the way you should drive on each lane. Then this is managed also in the R-shoulder management, which allows the R-shoulder to be transitable or not, depending on specific conditions in the road. And this is mostly managed in combination with the dynamic lane management itself. But also in common roadwork management, like in the picture that has been showed by Joseph in the previous presentation, we have a specific fixed regulation for each lane, which are managed by static sign put on road by the roadwork to place the roadwork. So the goal of the model had been to optimize the information management with location details coding the exact lane management information. It's a logical lane description and logical lane about how are the driving rules on the lane. That has been done, of course, with a total reuse of the current location referencing model developed sorry, this is not ISO, it's an EN 16157.2. Reuse of traffic regulation has been developed in the current METR traffic regulation model shown by Joseph. The application are the optimized and accurate information description for dynamic lane management, R-shoulder management, and roadworks zone, which aim to support to deliver the information most suited into the in-vehicle information, more potentially usable from the vehicle in ITS services. I mentioned here, it's the NEM messages, roadwork management use cases. Further road carriageway feature description associated with the road are being developed. And there are in the SICAM field some more features that are associated to the road, to specific lane and section that will be explained in the following presentation. That is interesting to understand how this model could support this information to be delivered. And so this is something to be further analyzed and taken into consideration for the future. This is the lane management currently available in DATEX 2 version 3. We have a location. Location is the location referencing information that are mostly for situation in a network location, which may be both point or linear location. point location when the event, the situation record is relative to one specific location, and the linear as an extent. But there is one, and I should mention one possible option of having a supplementary positional description, which give you a further detail. Because the point location and linear location are depending of the standardized way of the location referencing, that we may use both GML string or GPS coordinate, but also LRC or TPEG location referencing or ISO linear location referencing, but they had not the sufficient detail for managing all information, that we needed to add this supplementary positional description, which is one, and this description is linked to the carriageway, eventual carriageway of the road in that place that are affected by the situation, and the specific lane. In the carriageway, we have an original number of lane, meaning the nominal number of lane which could be available in that location, and the specific lane that could be occupied, for instance, by accident or roadwork. And for any lane, we can say there is a lane number, which is important in our modeling. 0 is considered to be the harsh shoulder. Then 1 to n is the transitable lanes from right to left or left to right, depending on the continent or UK-based location you are in. The lane usage is further information that could be used to specify the lane, meaning it's a slow vehicle lane or overtaking lane. So there is a number of carriageway and lanes which are affected by the location, which can be considered. But as this is based to one location, we have seen, we have only one possibility, we have only a combination possible. And so if you need to define different combination, how the roadwork evolve along the road, you need to manage multiple situation record, each one describe a precise location and the section and lane configuration. So let's go now the real case that we want to see. The dynamic lane management is done by a specific lane control system that are called LCS, lane control system, VMS. Any per lane restriction which applies are advised and granted by the VMS. So any speed limit or special vehicle which are allowed for lane are defined by specific signs. And mostly in this kind of application, there are a huge system of traffic sensor and monitoring for understanding and allowing the better management and safe and secure management of the road. And there are also, as you can see, the tunnel management application are available, which allows to define each specific lane if it is closed or open, and eventually any advice or speed limit. As shoulder management is a bit besides this, you can allow the usage of the harsh shoulder when available in certain traffic conditions which grant the safety level. This is an application that we have in Italy, in Bologna area run by Autostrade. We have a dynamic shoulder lane management in the motorway zone, which is around Bologna, which is a two-lane with emergency. And the emergency lane had been, the harsh shoulder had been used to enhance the traffic flow in specific traffic conditions when there are no road work, no accident, and no huge traffic flow. but it should be well described. Dynamic lane management and Archalder management application. There are two stretches that are managed in a different way. So they are independent, but they are part of the larger, huge Bologna area where we manage the dynamic lane management and Archalder management. So you see here is the motorway, which has the 3 lanes, which are managed by the lane control system. The other place it's an open road. It's not a motorway. Where we have the management is the internal carriageway where the motorway is. You see these are lane control system, which are done by a pictogram with a speed limit or other information, and the traffic light for the lane. This is traffic signal for lane, which show the lane is open or deviated or closed. As it was depicted here, we have different segments. We have called these segments where the same management applies. If I decide to take the Archalder open, I manage this segment or 2 segments or both, or each segment independent. But within the segment, all this information is the same. So it's managed consistently in the same way. So we have 2 zones per direction. We have 4 segments. So as we find some naming convention for this management. We have a zone, Bologna area Archalder management zone. We have 4 segments, which are for each direction, the 2 segments which has the consistent Archalder management possibility. So we switch the Archalder only per segment. After then, here I have all the lane control system along the motorway. And these are shown for each section. We introduce the section definition. Section is a section which is managed by an appropriate lane control system, and alternatively with a VMS to reinforce the information, which manage the lane status very precisely. These are placed any 500, 800 meters, for instance, which is based on the road morphology, and LCS and LCS plus VMS are alternated on the road. So zone, segment, section, and lanes. These are the hierarchy of the information level management. This is an example of the normal condition of the road. This case is a 3-lane plus Archalder, so it's a 4-lane when the Archalder is running. And we have any section, alternate section as VMS or not, and the lane control system are on any section. So we can switch and we can control the regulation for any of these sections based on the lane control system. For instance, normally we have a condition of no heavy good overtaking section, and so the heavy good vehicle are only on the Archalder running or on the fast transitability lane, which is mandated also by this sign, which do not allow the transitability of the ban for heavy vehicle in the lane. And the speed information is also a very important to manage the traffic flow and to enable a smooth flow in the motorway. So lane speed limit and VMS. When something happens, there is an automatic control which switch the lane control system to manage. For the first thing is setting a hard shoulder when there is an accident or anything that may be an emergency situation with safety issues. And then we protect the accident area, deviating the lane and closing the lane at the accident position, managed by the section here. So we have speed reduction in operation, and we have accident closing the lane, which has been previously deviated in a reduced speed management. And also the normal VMS gives information about the accident in approaching. So this is a specific lane management for each lane, which is achieved by the lane control system. The other use case is the roadworks that has been already shown by Joseph. General roadwork management along the road implies lane management, of course. And depending on number of the road configuration and number of lane involved and closed by the roadwork, several options are available. The lane are closed, deviated, reduced with reduced, or can be also used in an alternate one-way traffic, or I would add reverted, we'll see later. The number of lane lead to several options of lane combination, and there is specific rule are to be applied in a different road type. The road manager knows that if they have 3 lanes and they have to make roadworks on the emergency lane or to the first transitable lane or to the leftist transitable lane, you should apply different road configuration. For this, we have specific guidance, which is defined by the road code. And the road code, then, it is applied in the different motorway or road section based on the number of lanes. And so this is a specific, precise information that is applicable when you close, for instance, in a 3 lanes plus a shoulder motorway. You have this with this section and this sign on act. As you can see, we after we close the lane, we have several sections. I will name with this name. Any place I have a different regulation, I call it a section. Or when there is a change in a lane configuration, I call this a section change. And so I may find naturally by the roadwork management this concept of section again, which allows a section as the homogeneous management inside. So any section here is introduced to display and to code a different specific situation. We have 3 lanes, we have a speed reduction, we have no overtaking for heavy good vehicle, and then we have the lane is transient, so it's merging, and so it starts to be deviated, and then we have 2 lanes operating instead of 3 lanes. So these are sections. We call this section as we had in the lane control system. Here are managed by specific sign, static sign that are set at the roadwork. The lane status is open, closed, and deviated. Then these are some different framework that can be seen. The road perspective, this is the specific regulation. So we know that if we want to operate such closure or deviation, we need to put in place such regulation for each section and at a specific position. So this is an array of sections, one after each other, which are delimited by specific intermediate offset. And they have an extent of some meters. And you can arrive, you can manage also very complex situation. And here is near a junction, you have a lane is deviated on to go in a direction, the other lane is passing to another deviated lane in another carriageway. And so here you have very complex situations that are also merged with this junction. We in this model manage a logical configuration of the road and the logical status of the road, not the physical, because the physical layer is to be linked to the map, to the cartography, and we have connection also and input from the studies and the standardization process undergoing into this field for GDF, which we had, from which we had some inputs, and we will keep on taking something, because we need after to associate this cartography information to the logical management that we are describing here. And this is a future project that is undergoing in our domain. So we did this modeling with the DATEX 2 methodology based on reuse and our experience management, and this is the thing. Both for roadworks and dynamic lane management, our child management zone, the lane management model support what I want to call a natural description of the road along the road, as it's seen developing on subsequent section. For instance, if I am a vehicle moving along, I see all these sections one after the other in my direction, optimizing the lane status information management based on the assumption of this structured location referencing per section, segment, section, and lanes. That reminds me also something that is, if any one of you is used on traffic flow TFP, TPEG messages, they have this concept of giving information each in an array of what I would say section that are specific length segments, section of 500 or 1000 meters, one after each other. This describes the carriageway and lane and their status setting as by road sign, as set by road sign, VMS, LSCS by. We have a dynamic lane management table publication that specify how the road is managed, which are the lane control system that are set along the motorway for dynamic lane management application. And then there is a lane management publication which gives the information on real time, the management itself. The table is used always when you have a specific sign that you set in the road for management of the dynamic management. When you have roadworks, you manage only the dynamic information. We'll see. So, lane management table, how this is the model. The model represents the concept that has been explained. There is a table. A table is used to manage the zone. The zone are one or any. We have Bologna, we have Milan area zone. Any zone identify its segments. The segment, you see, both the zone as a location reference, because it's normal to have a location reference, and the segment as its specific location reference. And here I would say that a specific location reference would normally be a linear location reference, but we use to point to location reference to allow also predefined location delivery. So it's a linear location reference. The segment are connected. So I have from one segment, I pass to the other segment, and I can specify this driving to, driving from. After we have section, and here the section are identified by an index, which is the subsequent number that I found them in the road in the specific direction of the segment. And then the index has the section length, and there is an offset, of course. These are the defining the structure of the road in that part. Let's go a bit further. Okay, here the location we put optional, because we can specify the precise location, but as we gave the location reference of the segment, we may assume that the section has the location that is identified by the index and the offset and the length. So in a linear, we have only this information is enough. But if we want also to specify the specific location reference of the section, is possible. That's the same for the lane. The lane are identified by an index, which is 0. 0 is for the hard shoulder, as we said, and 1, 2, 3. But we also specify the lane usage, lane number, as they are in the situation, in the location referencing model. We reuse the same concept, and other information that belong to the lane as a static lane. So it is reversible, it is transitional, because also we can connect the lane in a GDF way. We can have lane splitting, lane merging when we have a section which pass from 3 lane to 2 lane, because the road is done like that, and not because of the dynamic management. So this is the structure of the road, in which we add also other information, because we have devices in the segment, section, and lane specifically divided that are dedicated to segment management information, to the section information, the LCS normally, and the VMS besides any section, or specific lane information either, because the lane is, any lane is controlled by one specific VMS. Also device, I put device here because we don't have only VMS, we also have traffic measurement sites, we have traffic cameras, speed cameras, or anything that could be put in this complex architecture of the dynamic lane management, and so the device is a generalization. This hook class allows to plug in VMS or measurement site data or speed cameras or whatever. We have the same information here, which is a feature. The feature are the characteristics of the road. That can be managed in 2 different ways. We had the feature, which is a single feature which applies to the segment, section, or lane, can be specified here as a feature. But when there is an applicable feature group, because the same feature applied to the whole section or to all the lane, it could be much more optimized to describe the feature group that are applied to any section or to any lane. And so the applicable feature group can be specified associated to the zone, and then the features are associated by reference in each lane, section, and segment. There is a feature group reference that link to the feature definition as it has been assumed in the previous. So this is an optimization of having feature, use of feature group within the section, the lane of the segment. Otherwise, we can, if this is not the case, like device, the same device are not in the same place, so we use the specific device for any of these. So one example of a feature is a specific traffic regulation which apply in that segment. So For the segment, for instance, we have a specific traffic regulation that allows the speed to maximum speed of 1110 kilometers per hour, for instance, and this is applied anywhere in the zone, and so this is kept. The speed can be then lower than this, but the uniform speed is managed at zone level or segment level. Okay, I would add that as a feature, really, here, I mentioned a few things that CCAM people can understand, support to HIZAD level ODD, that can be described, associated to this segment or section. That could be a specific way to convey the information associated on a zone, segment, section, lane structure. After we have the static, we go to the dynamic. Dynamic means that we have a lane management publication with a lane management setting description, which is specialized in two classes, which one is for the lane management setting, which is applicable to the dynamic lane management zone that has a table, and so there is a reference of a table, but can be also defined on the fly for the roadworks which do not have a table on which they can base on. Of course, they have validity because they have the information of the lane management is valid due to the programming, is a start time and end time and so on. Still, we use a lot the applicable feature group also in the dynamic concept. Let's see the two different lane management for the table predefined zone or on the road. The predefined zone as the setting of the segment, lane, section, and lane. So starting from the zone section, we have the segment, section, and lane, which has its own feature or the applicable feature group, which is referenced within. And a lane setting also as a managed linked lane, because here, when dynamically available, we have the lane deviated is merged to another lane. And so we can indicate it is explicitly from which lane to which lane we are doing. We will see after the example in the construction of this. The dynamic lane carriageway description allows the dynamic information, for instance, for the roadwork. So there is a dynamic lane carriageway description which has a segment which should be the whole roadwork area, then the section which are set as the homogeneous lane management and regulation management area sections, and then the lane status. On each of these we have the feature, a possibility of application of a feature, which is a traffic regulation, different traffic regulation, for instance. We could have also some on-the-fly devices, like, I would say, CITS station or specific VMS for dynamically managed. So it's a mobile VMS which can be set in those locations. So of course, in the dynamic model, you need to specify the location with the same rules that we do in the table. So we have a segment location is mandatory, and the section and the lane can be optional because it can be set by the offset index and the length extent of the section. So these are examples. It's a bit complicated, I know, because we have it has not been. This is a grid structure from the XML, which applies in a very linear, readable way of the XML, because after we have the dynamic, the DLM zone, the DLM zone is here in this section. Then we have the feature group which apply in the section, and after we have the segment which its section, each of which may reference specific feature group. So at the end, the interaction on this shows that each feature group is linked to traffic regulation model, for instance, with a speed limit that are instantiated, or overtaking ban, and these apply in the different section. So the section index 1, number of lane 3 is harsh shoulder, slow vehicle lane, overtaking lane. It's a reversible, false, transitional, false. Feature group reference each lane speed limit that had been set for each lane. So this is a very compact description of the section where I have this. The dynamic setting is linking the table, the zone reference, and the table. I had a roadwork example also, which this will be deployed then in the sample area of the website. I want to show you, I see it's a bit on the limit of our time, the work done to develop with another methodology than Joseph had. So we will compare the methodology and the coordinate decision. Here we have this the schema, the concept of the roadwork management with speed limit and overtaking ban. This is a complex case where a lane is kept on the motorway that is only for heavy vehicle, or heavy good vehicle are mandated to run on this lane, while light vehicle can also run in the deviated lane. And there is a one lane is closed to the traffic, and the lane is deviated to another lane. And this is the logical description with a color set here, that we put a section of 3 lanes with harsh shoulder and 2 lanes. This is here, of course, there are the speed reduction. Any of these line identify a transition of something, some regulation, so we need a section start. We have the deviation, that the deviation we consider to have this deviated and this available. So we have at the end in this section 4 lanes. We consider to have the lane closed, the second lane closed, and the third lane added. So at the end we have 2 transitable lanes, but we have in a nominal 2 lane number, we have a new lane from the opposite carriageway. While in the opposite carriageway there is a similar schema, which is managed with speed reduction section, and then the lane has been deviated, going to a 1 lane configuration. So it's a lane reduction with only 1 lane. So based on the opposite direction, we consider the lane closed. So it's reversed, it's used by the other flow direction, and we consider to have only one transitable lane and one closed in the opposite section. And this is a huge model that has involved us, me and Simone, for a few days to discuss all the configuration setting. So based on that nice Excel file methodology for defining the schema. So I won't resume, but this is the specific section management. Any section has a speed and speed reduction deviated, and we introduce this deviated to left and the section reversed open to this traffic in the opposite direction. So I have the conclusion slide only to resume that we had done this huge work on modeling to manage specific use cases, but we think that we delivered a compact optimized model to derive, for instance, the information in the best suited the way for CITS, DLM, Roadwork, and IVS messages. Model will be published and as a proposed starting model and should be assessed against other possible usage and better measured and unified with the traffic regulation model as well. Describing also possible road feature and device along the carriageway, and let's see how this could be also used to support other features.